Hello, and welcome back to another episode on math and science problems. Thank you so much for tuning in on today's video. But before we begin, please make sure to like, share, and subscribe, and turn on post notifications when it comes to any other new or fun, interesting videos that you may need help with, you're curious about, or you just genuinely or generally want to learn. Now, let's get right into it. So for today's video, we are going to be talking about the secant line. Now, a couple of videos ago, we worked with the tangent line, and the tangent line gave us perspective on how we are able to understand a line in terms of a graph perspective and how that kind of correlates to formulas, calculus, things in that nature. However, the secant line is something that is very, very special, and it kind of correlates to the tangent line. So, for the secant line, say we have a graph. Okay. And for a graph, say we have a circle. Let's do the circle in red. This is our circle. Okay. Now, secant lines, so secant lines essentially are lines that only touch a graph once. So, for short, sec is equal to 1. And in our previous video, if you haven't seen that one, check it out before you continue with this one. Give you a second. Okay. So for our tangent lines, they touch twice. Now that's very important to note because when we understand both of these lines in its own perspective, it's very easy to not only be able to differentiate them both, but it's also easy to mix them up if you don't know the difference. So this is our legend. Okay. So for a secant line, so say we have our graph and we have our circle. Now say we wanted to find the slope of a specific point on the graph of this circle. So say I wanted to find the slope right here. Okay. To find the slope right there, I would need to know the rise and the run to calculate that. But it's very hard to calculate that because it is not linear. So this is where secant lines come into play. So I'm going to draw, keep the same color. I'm going to draw a line, and this line only touches the graph once. Okay. So as you can see right here, this secant line only touches the graph once. And this secant line is a representation of the slope at that point. Okay, now let me repeat that. This line, this green line, represents the slope at that specific point. Okay. To give a better understanding to that, when we understand a linear line in the y equals mx plus b form, the slope of this line is uniform and constant throughout the whole entire thing. For this line isn't touching anything, it's just a line. In that same respect, the secant line resembles the same aspect and characteristics of a y equals mx plus b form line, linear. However, in this secant line's case, we are able to interpret what a specific slope is of a point for a different graph. So this graph is this, but it helps us understand the slope of another graph. So that is what the secant line is used for. Now, in calculus, the secant line is very helpful because when we're calculating derivatives, and dy dx, the derivative for the circle would be whatever blank. Okay, that would be this derivative. Now the secant line or the tangent line, secant line only touches once, but it's actually a tangent line. So the dy dx of this point, let's just say it's 3.5, negative 3.5. Okay, that is what this line resembles. That is exactly what this line resembles. Now the difference between a secant line and a tangent line is that a tangent line is just multiple secant lines getting close together. So when we look at another graph, and let's just say we have the same circle, and we're going to keep this format. As we noted before in our legend, the tangent line touches twice. So if I still wanted to find this specific point right here, I would have a tangent, another one, another one, another one, and another one. And this one that I'm about to do again in a dark blue is equivalent to this secant line right here. So a tangent line is a secant line, but it just is not as developed if you want to think about it that way. So in our multiple green lines, these are all tangents because they're touching the circle twice. But the secant line only touches once, and it allows us to find our derivative of the circle on the graph. Because the derivative is essentially just saying, what is the slope at this point? What is the slope of this? And this is how secant lines allows us to help manifest that. So that is the difference between a secant line and a tangent line. Essentially, a tangent line is a line that touches a graph 2 times. Tangent lines are also commonly known in calculus for understanding the slopes of things, as noted as the secant line right here. But secant lines only touch a graph once, and they are a tangent line. So it's kind of like this, kind of like a paradox. So all actually some so some secant lines, some sec are tangents. Actually, all secant lines are tangents. So all secants are equal to tangents, but all tangents are not equal to secants. This is a great way of saying it. So all secant lines are tangents. Secant lines only touch once, and a tangent can either touch twice or it could touch once. So all secants are tangents, and that helps us find the derivative of a point as noted in these circle graphs. But not all tangents are secants. The requirement for a secant line is for it to touch once, but since a tangent line can touch twice, not all tangents are secants. Thus, this helps us better understand how tangent and secant lines are correlated, and how that overall helps us understand derivatives and calculus and overall in geometry when calculating slope. Thank you so much for tuning in on today's video of the secant line. I hope you enjoyed and you were able to gain foundational information when it comes to using the secant line to help you understand math better. Please make sure to like, share, and subscribe, and comment down below if you have any questions about anything or any preferences for future videos. As always, thank you so much for listening, and I hope to see you on the next one. Take care.